Welcome to lesson 48, solving systems, a cumulative review, meaning we're just going to do one more day of practice with all of them. And in this one, we want to determine which might be the most efficient method. So that's what we're looking for, efficiency in our systems of equation, and determine accurate solutions for our systems. Now, I will say that although something may be efficient, it may work just because of the way equations are written. Or it could just be you're really fluent in one of the forms and you'd rather use that one. Now, I will say sometimes on the Regents, it will ask you to do a particular method. But if it doesn't, fair game, you get to choose whatever you want. So here are just some of my thoughts on what would make an efficient strategy. Okay, so what makes the most sense, meaning I don't have to do a lot of effort in the beginning to set it up. So graphing is really great if I already have everything written in slope-intercept form. Why? Because as long as I have slope-intercept form, if you give me some graph paper, I can graph it pretty quickly. We know how to do that once you have M and once you have a slope, we know how to graph equations. So that's one way. Second method, substitution. It's really efficient when at least one of the variables is already isolated. So when a variable is already isolated. So if you already have X equals something or Y equals something, then it's already set up for you to substitute. Like I don't have to do any extra work. It's already set up. I can just, substitute that expression right in. And the third one, elimination, is pretty efficient if they're both written in standard form, because I could stack them and look for zero pairs or make zero pairs and solve. But honestly, the one that makes the most sense is whichever you feel most confident and consistent in. So I feel great using this method and I get the best results. Like I consistently get the right answer when I use that method. Then that's the one you'll probably want to go with. So let's look at our model. I have the equations 2x minus y equals 3 and x plus y equals 3. So just using some thought, I would say this is already set up for elimination method, but I'm going to do all three. So here, all I'm going to do is start stacking. And I'm looking for a zero pair and I already got one. These two eliminate, so that does that. So now I have 3x is equal to 6. X is equal to 2. So I have one of them. Now I'll just substitute it into one of the other ones. Why don't I use a simple one? X plus y equals 3. 2 plus y equals 3. And y is equal to 1, which means my solution is going to be 2, 1. All right, hit pause and jot this down into your notes. Great, so let's try with another method. You can see that didn't take a lot of time. So let's say you decide to choose substitution method because you like substitution method. I would take one of these and I'm going to decide to isolate. So I'm going to subtract y on both. So now I have x is equal to negative y plus 3, and I'm going to substitute that in. So I'm going to do 2 times the negative y plus 3 minus y equals 3. And I get negative 2y plus 6 minus y equals 3. Combine like terms. And I also get here, when I divide by negative 3, I get y is equal to 1. So automatically, see, I did a whole different method and I still get that same y equals 1. So now I'm just going to go back up and I'm just going to substitute when y equals 1. So I will do the same thing. Use black. x plus y equals 3, x plus 1 equals 3, and I get the second answer, x equals 2. So there you have it. I did a whole other method and I get the same solution, 2, 1. All right, so hit pause and jot this down into your notes. For our last method, again, I want to graph them. So all I'm going to do is I'm going to just put those 2 points into decimals. So let me hit pause and set this up. Okay, here we are. I just put both equations as is, and you can see the point of intersection. I've looked for it. Here it is, 2, 1. So I just put it on my graphing calculator, and I still get 2, 1 as a solution. So look how quick is that. But ultimately, it doesn't matter which one you decide to use. All of them are going to give you the same answer as long as you do your algebra correctly. All right, now it's your turn to try. Here are your 2 equations. Which method would you like to choose, and explain why you've decided to choose that method? So hit pause and try this for yourself. Okay, so if you did this on your own, you would have what? I'm actually going to use graphing to check the solution. Okay, here we go. I've put both equations in and we have an actual solution at 2, 2. So here's with graphing. So check to see if you got the answer 2, 2 as well. If you use graphing, you can see it pretty easily, but if you did substitution or if you did elimination, you also should have gotten 2, 2. Now my first thought was the easiest method this was most set up for was substitution, because we have x is equal to 4y minus 6. So I can easily just sub that in for x in this first equation. And when I combine my like terms, sorry, there should be a y here, 3y, I get 7y minus 6 equals 8. 7y is equal to 14. And y is equal to 2. I'm trying to save some space. Okay, and that was the same point. I had 2, 2. And then I would have just substituted into the equation from the beginning. So x, I like writing black. X plus 3 times 2 equals 8. X plus 6 equals 8. X is equal to 2. So that would have been the second one. So that was my idea about which one was the most out of all of them, which would have been the easiest one to use. And I would have written that into my answer, that this equation is already set up for a substitution because x is already equal to 4y minus 6, and I can easily substitute and solve for y. So that was my choice. Now, if you decide to choose substitution, the challenge is, why I wouldn't have done it is because they're not in the same form. Like look here, I have, put it in black again, I have x plus 3y equals 8. So that one's in standard form, but the other one is not. So I can't do this without having to change this equation. So I'm going to have to subtract 4y from both, and then I can do it. All right, now I can do this part of work, but notice I don't have any 0 pairs. So again, elimination, not the easiest one to use. I do see x and x, so I'm just gonna multiply 1 by negative 1. That's it. So now I have negative x minus 3y equals negative 8. These cancel out. And I have negative 7y is equal to negative 14. And now it looks like the other equation. So you can just see it where y equals 2. And then you would substitute again and you would get what the other number is. So that's it, Math Marbles. Again, you can use whichever one you like. We want to make sure you're fluent in all of them because there may be times where you are asked to perform a particular method and you have to make sure you know how to do that on your own pretty well. even though you'll probably have a favorite. And I guess I think I know which one it would be if I were to make a guess. That's it for today, Math Marbles. I'll see you in the next lesson. Be well.